Hi guys, Dr. Diaz here again. We're going to start solving problems integration by parts. And look at this one. It's actually the last one that I showed you in the previous video. Let's integrate this integral. Looks like innocent. Yeah, look at this. It's the integral natural log of x. But actually it's very complicated to solve with this one. So the first thing we're going to do, if you remember, let's put here again ilate just in case. We remember how we go. First thing we're going to do is let u. Okay, so logarithmic is actually one of the first, along with inverse. So let u be equal to natural log of x. Then du, what's the derivative of natural logs? Is actually 1 over x dx. Now dv is, if we already choose this one as natural of u, then what is left here, dv is going to be actually my dx, right? And then the integral dv is going to be v is equal to the integral dx, which is just x. So v is equal to x. Now, using the definition of integration by parts, which means if you have something like, I wrote it here, integral u dv is equal to uv minus v du, then what we have to do is just substitute who we call u. U is natural log of x. So the integral will be, in this case, well, actually, the integral is the integral natural log of x dx is equal to, who is u? Natural log of x. Who is v? V is just x. So let's put here the x in front of it, right? So because if I put it here, natural log of x and x, you might confuse and then put natural log of x squared, and actually they're two different things. Minus the integral who is v again? V is x, and who is du? Here is the u, right? 1 over x dx times 1 over x dx. And this is the beauty, because this x and x cancel. The only thing you have here is the integral of what? Of dx. This is x natural log of x minus the integral of x and x cancel of dx. What's the integral of dx? It's just x. So the answer is going to be x natural log of x minus x plus c, that is the integral of natural log of x dx. Voila, simple, right? Okay, great. Now let's do this integral here. This actually looks similar to the one we just did a moment ago, that it was doing by integration by substitution. However, this one has slightly some kind of complicated. Is that in this case you couldn't have said let u be equal to x squared, and then du, you're not going to get something that is x, is going to be 2x dx, and you have another x there, extra x. So it's not going to work by substitution. You have to do what? Integration by parts. Now I'm going to show you in a second. So in this case, the first thing we're going to do, remember ilate? Remember ilate, guys? I-L-A-T-E. Well, algebraic before trigonometric, right? Algebraic trigonometric. So let's say let u be equal to x squared. Du is going to be then 2x dx. Dv, this is how it always works. You choose u and do the u, and then dv, and then integrate dv. And dv is going to be sine of x dx. And v is, what is the integral of sine dx dx? The integral of sine of x is actually minus cosine of x plus c, right? So in this case it's going to be minus cosine. We're going to put just minus cosine. The plus c, we will do it at the end. Okay, now we go with the formula for integration by part. It says u dv is equal to uv minus v du. And now we have to do this integral is what? This basically says that x squared sine of x dx is equal to, who is u? X squared. Who is v? Minus sine. So let's put a minus sign here and put cosine of x minus the integral, who is v? Minus sine of x. So it's going to be minus cosine of x, I'm sorry. And who is du? And du is going to be 2x dx. So this minus sign cancel. You keep going here, you have a minus x squared cosine of x. Minus minus will be plus, it's going to be plus integral of 2x cosine of x dx. Well, this one does not look, well, this part we get rid of this thing, we're done, but this part here, it still looks a little bit complicated because this is one of those cases in which you had to do integration by part again. And actually the example on the PowerPoint says repeated integration by parts. So this one we have to do the integration by part again. So let's say who is u? In this case, let u be equal to x, because we can take the 2 outside as a constant. So the u is dx. dv is cosine of x dx. So v was the integral of cosine sine of x. So let me scroll this down a little bit. Okay, I forgot the dx here, the x a moment ago. Okay, I just put it there. So now let's substitute all these values here. So we have, this is equal, this stay the same, minus x squared, because we already integrated that part, cosine of x, plus, who is u? X. And who is v? Sine of x is going to be x sine of x minus the integral of who is v? Who is v? Sine of x. Okay. And who is du? And who is du? It's just dx. Oh, look at this thing. Now this integral is very simple, because what's the integral sign? Minus cosine, right? And minus minus is going to be plus. So here we go again. Write this equation. Minus x squared cosine of x plus x sine of x, and it's going to be minus, but it's going to be minus cosine of x plus c. The minus minus is going to be plus, so at the end we will have that this integral, which was x squared sine of x dx, is equal to minus x squared cosine of x plus x sine of x plus cosine of x plus c. Voila. Great. Okay, I'll do another one. Okay, now we're going to do this integral. This integral in the PowerPoint says repeated integration by parts with a twist. And it's because this one you would end up actually doing two times the integration by part, and then you have to do something crazy, which is you would end up with the same integral that you started with. And I will show you how to go. So let's start working with this one. The first part we're going to say is who is going to be u and who's going to be dv. So here we're going to set, let's let u be equal to e to the x. Let u be equal to e to the 2x. Then du is equal to 2 e to the x dx. Then we say let dv be equal to sine of x dx. So then v is equal to what? Minus cosine of x. Yeah, okay. Yeah, but that's basically the integral sine of x dx is equal to minus cosine of x plus c. Okay, so we got here. Now we go back to the definition, or the tool we're using here of integration by part, that it says u dv is equal to uv minus v du. So in this case, who is u? So basically what it's saying is that the integral of e to the 2x sine of x dx is equal to who is u? E to the 2x, right? Times who is v minus cosine. So let's put a minus sign here and put here cosine of x minus the integral of who is v is minus cosine of x, and who is du? Du is times 2 e to the 2x dx. Oh, and I forget there's a 2 here. Okay, now it's perfect. Okay. Now, what happened? Well, we keep going here. We cancel this negative sign. We have minus e to the 2x cosine of x plus the integral of, let's take the 2 outside, and it's going to be e to the 2x cosine of x dx. Well, yeah, okay, it's not exactly this one, because this one is cosine, but it means that we had to do again another integration by parts. So here we're going to say the same thing. Let u be equal to e to the 2x, so du is going to be equal to 2e to the 2x dx. dv is going to be equal to cosine of x dx, and v is going to be equal to sine of x, as the integral of cosine of x. Okay. Oh, if you remember here, ELATE usually says that the last two is trigonometric and exponential. Well, in this case, I choose exponential first, but you know, some things work, some things doesn't. But the good thing is that integral, sine, and cosine, you know those well, and the integral of e to the x and derivative of e to the x, you always get the same answer. So in this case, I started with letting u be equal to the e to the x, and it's working. So I'm going to scroll down a little bit this so we can keep working on this problem. Okay, so now we keep working on this one. Let's say this is going to be minus e to the 2x cosine of x, because we have this one, plus there's the 2, and okay, we did a bunch of other stuff. We did, who is u? Here in this case, u is going to be e to the 2x. Who is v? Sine of x minus the integral. Who is v? Sine of x. And who is du? Times 2 e to the 2x dx. And let's close here the bracket. So yeah, there's a 2 here because this 2 come from here, right? Remember this 2? Let's not forget that one. And everything's going to be multiplied by 2. This part of the integral is already solved, so we can get it out of the integral. Let me move this equal sign a little bit here, like this. Minus e to the 2x cosine of x plus 2e to the 2x sine of x. And these 2, we can take it outside the integral. And this 2 times that 2 is going to be minus 4, right? Because there's a 2 here, and there is a 2 here. So that 2 times 2, there's a minus sign, it's going to be 4. And we go here, the integral of e to the 2x sine of x dx. And here's where we stop and say, wait a minute, isn't this the integral that I start working with? Yes, it is. It's here. And if you roll up, yeah, we end up to this with the same integral. How is that? Well, here's the twist. What we have to do now is we take this part of the integral, we send it to the other side, and regroups the integrals that are the same. I'm going to do this in a second. Okay, you remember this integral? Yeah, put it here. Basically, this is where we are now. This integral, the one we started, we end up with the same integral. So what we're going to do is going to send this 4, or this negative 4, integral of e to the 2x sine of x dx to the other side. And doing that, we will have these 2 integrals the other side. It will look something like this. This is how it looks. We have sending this integral to the other side, goes as positive 4. And they are the same integral, so we can add it up. It's going to be 5 integral of e to the 2x sine of x dx. Now we divide everybody by 5, like that, and this is what we're going to get. And this is what we get. Well, 1/5 is going to be 1 minus 1/5 e to the 2x cosine dx, and plus 2/5 e to the x sine of x plus c. I forgot the constant c. And this is actually the integral. Yeah, you see, when you do integration by parts, and you get to the original equation again, what you do, you send that one to the other side, regroup those integrals, take that coefficient, whatever is left, divide everybody, and you get actually the integral of this one. It's a little bit more complicated and has a twist, but that's the beauty of this integral, is that you can use it. So I mean, this technique, you can use it, you can still find the integral by using some of a twist, like they call it. Okay, guys, I hope this helped a little bit, and I will do other 2 more problems later, because this video is getting longer. Okay, take care.